Hello friends, welcome back to my YouTube channel Structural Funda. Myself Ethan Kenny, and today we are going to learn about column based footing for composite section as ISMC Indian Standard Medium Channel Section of height 350 mm with 220 mm back to back spacing to resist the factor load as 1500 kN as well as the soil bearing capacity as 230 kN per meter square as given data. We have given grade of concrete as M25 and grade of steel as Fe415. So first of all, from the steel table for ISMC 350 we have the flange width as 100 mm. Another part is given as spacing between two channel section as S, which is equal to 220 mm. The height of given channel section is 350 mm. Thickness of web as 8.1 mm and thickness of flange which is equal to 13.5 mm. First of all, we are going to calculate the area of base plate. So first step is now from Indian Standard 800 2007 clause number 7.4.1 page number 46, the bearing strength is given as which is equal to 15 Newton per mm square according to FCK as 25 Newton per mm square. Now we have given the factor load as 1500 kilonewton. So area required which is equal to factor load or design load divided by bearing strength of the plate. So factor load is 1500 in terms of kilonewton, hence 1500 into 10 raised to 3 Newton divided by 15 as a bearing strength. So we require 10 raised to 5 mm square as a required area to resist the 1500 kilonewton design load. Now if we assume the projection all around the periphery as in the direction of spacing as 75 mm as a larger projection and 50 mm as a smaller projection, hence the width of base plate is 100 plus 220 plus 100 plus 2 times projection. It means that 2 times BF plus spacing plus 2 times projection which is equal to 570 mm and now depth of the plate is total height plus 2 times the smaller projection. So H plus 2 times the projection which is equal to 350 plus 2 times 50 which is equal to 450 mm. Now area of plate provided is equal to which is equal to 2.57 into 10 raised to 5 mm square which is greater than 10 raised to 5 mm square which is area required. It means it is okay to provide the 570 mm cross 450 mm as a base plate. Now let us calculate the thickness of base plate, and according to the Indian Standard 800 2007 clause number 7.4.3.1 page number 47, the thickness of slab is given by equation these value must be greater than thickness of flange, which is equal to 13.5 mm. Now A and B is smaller and larger projection. It means that A is equal to 75 mm and B is equal to T mm. Now W is uniform pressure. So W is nothing but the design load or factor load divided by area of base plate which is equal to 5.85 Newton per mm square. So let us put the value of W, A and B in terms of TS. We have which is equal to 17.71 mm, which is greater than 13.5 mm. It means that it is safe to provide greater value of 17.71 mm. We can provide base plate as 570 mm cross 450 mm cross 18 mm thick all around the periphery of our given composite section, and this base plate is connected by 4 anchor bolt at the corner of the base plate having 20 mm dia and 300 mm length along the concrete block to connect the base plate with the concrete block. Now going ahead for connection of this composite section with the base plate, we have to provide the angle cleat which is connected by bolted connection. Now going ahead for the calculation of the connection of base plate via angle cleat to the composite column. Now we know that we have to connect this composite section with the angle cleat, and the length of the angle cleat must be BF plus spacing plus BF. It means that we have to provide 420 mm length of angle cleat with 50 mm as a base width, because the projection is 50 mm, and the height along the column length must be greater than 50 mm. It means that we can provide 75 cross 50 cross 8 as a ISA, Indian Standard Angle section, to connect our base plate to the column via 20 mm HSFG bolt at each end. Now we know that the base plate area is 570 mm cross 450 mm cross 18 mm. So in terms of meter, our length is 0.57 meter and the width is 0.45 meter. So let us assume the projection all around the periphery as x meter. So our concrete block area is width of concrete block as 0.57 plus 2x, and the depth of concrete block is 0.45 plus 2x, where x is the projection all around the periphery of this base plate. We have given the factor load as 1500 kilonewton, and we know that the concrete block is designed for working load. So the working load is equal to factor load divided by factor of safety. So our design load is 1000 kilonewton for the concrete block as a working load, and 10% is taken as self weight of our concrete block. So the self weight is equal to 10% of 1000 kilonewton. It means that it is 100 kilonewton as a self weight. So total design load for the concrete block is equal to 1000 plus 100, 1100 kilonewton. Now next thing, we have given SBC of soil, which is equal to 230 kilonewton per meter square. Hence area required is equal to design load divided by SBC, which is equal to 4.78 meter square. We have to provide total 4.78 meter square for the area of concrete block. So our area provided is 0.57 plus 2x into 0.45 plus 2x, which must be equal to 4.78 meter square. So let us solve this equation. So we get x equal to 0.84 meter as a projection all around the periphery. So let us provide the projection as 850 mm all around the periphery. So our required area of block is 2x plus 0.57, which is equal to 0.84, and the depth of concrete block as which is equal to 2.50 meter. Let us assume angle of dispersion as 45 degree. It means that the thickness required is also the projection width, hence it is equal to 0.85 meter. So our area of block is 2.27 cross 2.15 cross 0.85 meter as a thickness of concrete block. So let us go for the detailing of our column based design. Thank you.